It was the 23rd of June 1944. The hedgerows of Normandy were still echoing with gunfire when a German patrol stumbled upon something odd among the debris of a destroyed American convoy, amid the twisted metal of jeeps and the charred remains of supply crates. A bulky olive-drab radio sat half-buried in the mud. Its dials were intact, its antenna bent but standing. To most soldiers it was just another piece of Allied scrap, but to the radio operators of the Wehrmacht, it was treasure. The squad leader barked orders, and the men carefully lifted the box onto a stretcher. The engraved marking on the side SCR 300 meant nothing to them yet. What mattered was the rumor, spreading through German signal units. American communications were unlike anything they had faced before. The captured radio was tagged and sent through the chain of command first to a local Funkhochstelle or listening station, then up the time poschentations, ladder to the Wehrmacht Nachrichtenversuchsabteilung, the Army's communications research branch. These were the men who dissected every enemy transmitter, every cable, every circuit, trying to learn how the enemy talked, moved, and thought. By the time the radio reached a small research facility outside of Berlin, the engineers already had a file waiting. They had tested British wireless set No. 19 before, and even a few Soviet RBM-1 second. But the Americans were said to be operating on higher frequencies with cleaner signals. When the crate arrived, the technicians unlatched it with curiosity and skepticism. The grey-green equipment inside looked simple, almost crude. The front panel bore English labels like tuning volume transmit, but when one of them noticed the serial number plate reading, Signal Corps, U.S. Army, Chicago, Illinois, a whisper ran through the room. So this is what's giving us trouble on the Western Front. They powered it on with a German supply unit, and the hum of its vacuum tubes filled the lab. The engineers took notes as the indicators glowed softly in the dim light. The first test would be simple: measure its output, power, its stability, and its range. The results would soon astonish them. But before that revelation, the men had to understand what they were really looking at and how their own technology compared. In the summer of 1944, deep inside a reinforced bunker outside Wiesbaden, a group of German signal engineers gathered around a long wooden table scattered with blueprints and schematics. On the wall behind them hung a large sign: Funk ist die Seele des Krieges, radio is the soul of war. To the Wehrmacht, this wasn't just a slogan, it was doctrine. Germany's early war victories had relied heavily on efficient communication. Panzer divisions that cut through Poland and France in 1939 and 40 owed much of their success to radio coordination between tanks, infantry, and air support. The German engineers in this bunker knew that they took pride in their Fug series radios. Reliable, rugged, and battle-proven. But by 1943, something had changed. Field reports from the Eastern Front and Italy carried troubling notes. American and British radio nets were clearer, faster, and seemed to stretch far beyond expected ranges. German listening stations were often picking up transmissions that by all logic should have faded into static. Inside the Nachrichtenversuchsabteilung, the Army's Communication Research Division, skepticism ran high. Some thought it was Allied deception, perhaps boosted signals relayed through hidden stations. Others suspected the Americans were using entirely new transmission principles. When the captured SCR 300 arrived, the team approached it with a mix of arrogance and curiosity. They had tested enemy radios before British No. 19 sets, Soviet RBM-1 second, even French pre-war models, and always concluded that German craftsmanship was superior. German radios were known for precision engineering, their coils wound to perfection, their casings sturdy, their sound crisp under ideal conditions. But the Allies didn't seem to care about ideal conditions. Their sets were designed for mud, rain, and chaos, for soldiers who needed quick connections, not flawless fidelity. The Germans didn't realize that this practical philosophy would soon humble them. As the engineers studied the American design, they expected crude circuitry and inefficient use of components. Instead, they found something that puzzled them: The internal layout wasn't messy, it was efficient. Components, he were standardized, labeled for mass production, and cleverly arranged for easy repair in the field. A young engineer named Eric Bauer, once a designer for Telefunken, muttered under his breath, "It's not elegant, but it works." His superior, Dr. Kurt Raschke, shot him a look. They weren't there to admire American work. They were there to measure it, to prove German superiority. So they began their tests. They connected antennas, calibrated instruments, and set up receiving stations, several kilometers apart. There, the goal was simple: determine how far an American soldier's voice could travel through this box of tubes and wires. The answer would stun them. The test began under a low-grey sky on the outskirts of Wiesbaden. The engineers had arranged a simple experiment: 2 teams, one with the captured SCR 300 transmitter, another several kilometers away with a receiver. Both were stationed on gently rolling farmland, the same kind of terrain that dominated much of Western Europe. The first team powered on the radio. Tubes glowed amber inside the casing. The signal operator turned a few dials and pressed the transmit switch. Testing 1, 2, 3 crackled through the air in halting English. A few seconds later, at the distant receiving post, a German technician raised his headphones, his eyes widening. The voice came through clear, not faint, not distorted, not buried under static, clear enough that he could hear the man breathing between words. They increased the distance, 5 kilometers, then 10, still clear. Engineers began exchanging puzzled looks. They moved even farther, 15-20 kilometers distances at which German field radios like the Fug 5 or Tornfud 2 would have already faded into unreadable noise. Yet the American signal remained strong, its tone sharp and unbroken. Dr. Raschke demanded a full diagnostic. "Are we sure the terrain is fair? Check for line-of-sight obstructions," he ordered. His team nodded nervously. The terrain wasn't helping the Americans. It was ordinary countryside, not ideal for transmission. By evening, after multiple trials, the Germans recorded what their instruments confirmed. The American SCR 300 had a consistent voice range of nearly 25 kilometers, under field conditions, and even farther when used at higher points or vehicle-mounted. That was nearly double the effective range of comparable German sets, Raschke wrote in his report. Reception is extraordinarily stable. The speech quality is unusually clear. This performance is not explainable by transmitter power alone. We must examine the modulation circuit. The engineers dissected the radio once more. Inside, they found features almost trivial in appearance but revolutionary in effect. The frequency modulation FM system caught their eye first. German military radios relied mostly on amplitude modulation AM, an older technique more vulnerable to interference and atmospheric noise. The American FM design, pioneered under the Signal Corps by engineer Edwin Armstrong, produced signals far clearer and more resistant to jamming. To the Germans, it was a revelation. They had long dismissed FM as impractical for battlefield use, assuming it required too much precision and power. Yet here, it was humming quietly on a muddy field. In France, performing miracles. When one young technician asked how such technology had reached every American platoon, Raschke gave a grim smile. "Because they can build 10,000 of these before we finish one prototype." That remark summed up the moment perfectly. The discovery wasn't just about range, it was about reach. The Americans had achieved a technological leap that the Germans, for all their precision, could not match in quantity or speed. By nightfall, the captured radio sat on the test bench surrounded by silent engineers. One of them finally said what they were all thinking. "We've never seen range like this." In the sterile light of the Wiesbaden lab, German engineers continued their analysis late into the night. Oscilloscopes flickered solder. Fumes curled in the air, and rows of American vacuum tubes lay neatly on the workbench beside piles of German components. Every wire, every capacitor was measured and logged. But the more they studied the SCR 300, the more they realized the secret wasn't just in any single part, it was in how the system worked together. Unlike many German field radios, which were designed by specialist firms like Telefunken or Lorenz for small batch production, the American sets were designed for mass manufacture by multiple companies. Simultaneously, Motorola, Zenith, and others all following the exact same standard. The circuitry used common tube types that could be swapped in minutes. The tuning coils were pre-calibrated, color-coded for field repair, and even the labels were soldier-friendly. Simple English, no technical jargon, one German engineer noted in his report. This is not a radio for an engineer. It is a radio for a man in a foxhole. That line said everything. Where German equipment was, crafted with surgical precision. American equipment was designed for the chaos of war. The SCR 300, for example, could operate on a simple 12-volt battery or even be powered by hand-cranked generators. It had waterproof seals, shock mounts, and a rugged metal case that could survive mud impact and rain. The antenna was collapsible, lightweight, and easily replaceable in the field, and the performance astonishing its use of frequency modulation FM meant soldiers could speak without the hissing and crackling that plagued AM systems. It also made it nearly immune to German eavesdropping attempts, since FM signals required different receiver designs. When a German intercept operator first tuned to an American FM channel, all he heard was silence, the sound of a signal his receiver couldn't interpret. The engineers realized something else too. The radio's crystal-controlled frequency channels allowed units to communicate on fixed stable frequencies without drifting, a constant problem in older German gear. American troops could switch channels quickly, coordinate across companies and battalions, and even link infantry to armor and air support with unprecedented reliability. Behind this technical triumph lay an industrial miracle. In the United States, the Signal Corps had worked hand in hand with private companies, universities, and the War Production Board to standardize every component. By 1944, America could produce tens of thousands of SCR 300 seconds and other field radios each month, enough to outfit nearly every front line. Unit Germany, by contrast, struggled to maintain even limited production runs. Under constant bombing, resource shortages, and bureaucratic inefficiency, Raschke's final technical evaluation was almost reluctant in tone. The American equipment achieves a remarkable balance of power, range, and simplicity. It is robust, efficient, and standardized to a level that our production methods cannot currently match. He didn't know it yet, but the findings would be forwarded all the way to Oberkommando des Heeres, the German Army High Command, with an urgent recommendation: study FM transmission immediately. But the war was already turning. The Allies were pushing out of Normandy using those very radios to coordinate strikes, faster than German units could react. For every German message jammed or delayed, 3 American transmissions were already in motion, guiding artillery, calling air support, and moving armor. The engineers could only watch in quiet frustration. They had uncovered a masterpiece, but it was a masterpiece they couldn't reproduce in time. By August of 1944, the results of those German tests had begun to echo far beyond the laboratory. The Wehrmacht's signal intelligence units on the Western Front were sending increasingly anxious reports. American radio traffic was constant, disciplined, and seemingly unstoppable. Entire divisions could shift position overnight, guided by orders passed through thin-air orders. The Germans could not intercept clearly, let alone jam effectively. In earlier years of the war, German coordination had been the envy of Europe. During the Blitzkrieg campaigns, panzer commanders used short-range AM radios to communicate with tanks and infantry, synchronizing attacks with frightening precision. But as the conflict dragged on, the complexity of German operations grew while their communications technology stagnated. The Allies, meanwhile, were moving in the opposite direction, faster, simpler, and more connected. The American SCR 300 and its vehicle-mounted cousins, the SCR 508 and SCR 528, transformed the way the Allies fought. A platoon leader could radio for artillery in seconds. A tank commander could coordinate with infantry without a runner. Air support could be summoned in real time. To the Germans, it seemed as if the Americans had found a way to make their units think and move as one organism. On the German side, the consequences were grim. Field commanders complained that radio interference, range limits, and equipment failures were costing them battles. A report from a panzer division retreating from the Falaise pocket described severe disruption of radio communications due to inferior range and jamming by the enemy German tank. Crews often had to rely on signal flags or motorcyclists, again tactics that belonged to an earlier era. At German listening posts, frustration grew. Their standard intercept gear was tuned for AM signals, yet much of the new Allied chatter was in FM. Even when they detected a transmission, decoding its content or direction was nearly impossible. The best they could do was note the activity and guess its purpose. For Allied troops, the difference was liberation. During the hedgerow, fighting soldiers used their walkie-talkies, the name they affectionately gave to the SCR-300 to coordinate assaults, call for medics and redirect fire under pressure. Radio discipline was drilled into every unit, creating a level of responsiveness that German doctrine could no longer match. One U.S. Signal Corps officer wrote after the war, "It wasn't the size of our guns or the number of our tanks that broke the German lines. It was our ability to talk faster than they could think." The Germans recognized this truth too late. Their own engineers submitted urgent proposals for FM development, but by autumn 1944, their industry was collapsing. Strategic bombing had crippled factories, copper was scarce, and vacuum tubes were rationed. Even if designed an FM set overnight, there was no way to mass produce it. The radio, once a tool of blitzkrieg, had turned against them. Where Germany's early victories had been driven by superior communication, its defeat was now hastened by technological isolation. The Americans' long-range clear, interference-free radios gave them something priceless: speed. And in war, speed was life. As the Allies crossed the Seine and drove eastward in September of 1944, the German engineering community went into quiet panic. In factories, laboratories, and underground workshops, frantic efforts began to replicate what the captured American SCR-300 had revealed. Orders were issued from Berlin to develop an FM field transceiver for frontline deployment as soon as possible. But in truth, it was already too late. Inside the Heere Signalprüfwesen, the Army's signal testing department, teams of designers from Telefunken, Lorenz, and Siemens were ordered to dissect the Allied sets and propose an equivalent. They called the project the Funkgerät mit Frequenzmodulation, Versuch 1 FM Radio Experimental Model 1. Within months, prototypes appeared on benches, crude, boxy, often overheating but promising. The engineers quickly realized that copying the circuitry wasn't the hard part. The problem was precision and materials. The American radios relied on high-quality vacuum tubes and tight-tolerance components, resistors, capacitors, and coils that had to be uniform across thousands of units. In Germany, shortages were so severe that even critical components were hand-wound and inconsistent. Replacement parts were often scavenged from wrecked aircraft or repurposed from civilian equipment. Then came the bombing. Allied air raids on Berlin, Stuttgart, and Munich smashed many of the same factories that produced military electronics. Entire research facilities were evacuated to tunnels or forests. Production lines were scattered. In one memo dated October of 1944, a Telefunken supervisor complained, "We can design it, but we cannot build it. The materials do not exist, and the power stations no longer function." Meanwhile, the Funkabwehr, Germany's radio counterintelligence service, begged for FM receivers capable of monitoring Allied frequencies. Their pleas went largely unanswered. Only a handful of experimental intercept sets were ever completed too late, and too few to matter. Still, a few German scientists kept pushing. In a mountain lab near Salzburg, an engineer named Rudolf Kiebitz succeeded in building a compact FM receiver, tuned to the same range as the SCR-300. His notes recovered after the war describe astonishment at the clarity and simplicity of the American design. The circuit is genius in its pragmatism. Every part serves more than one function. This is not artistry, it is purpose. But even as they worked, the front collapsed. The Soviets advanced from the east, the Allies from the west. Communications between units broke down completely. In some sectors, radios failed, batteries ran out, cables were cut. Field commanders reverted to couriers and hand signals, a grim reversal for an army that had once prided itself on radio-driven warfare. In April 1945, as American troops entered Bavaria, they discovered an abandoned German lab filled with half-finished transmitters and a single captured SCR-300 still sitting on a test bench. The German engineers had left in haste, leaving behind pages of measurements, sketches, and notes, evidence of a race lost not on the battlefield, but in the factory. When Allied investigators reviewed the documents, one line from a German report stood out. Our opponent's strength lies not in complexity, but in their mastery of simplicity. That single sentence summarized one of the most painful realizations of the war, that the American advantage wasn't just industrial, but philosophical. They built for the soldier, not the scientist, and that made all the difference. When the guns finally fell silent in May of 1945, the story of the captured American radios didn't end in the rubble of Germany. It continued in laboratories, intelligence reports, and classrooms across both sides of the Atlantic. In the aftermath of surrender, Allied technical teams fanned out across occupied Germany to recover every piece of military technology they could find. Operation Paperclip is often remembered for rocket scientists and jet engineers, but signal experts were just as prized. The Allies wanted to know what Germany had learned, and more importantly, what it hadn't. Stacks of documents from the Heere Signal Prüfwesen and Telefunken were shipped to Washington and London for analysis. Among them were the German test reports on captured US radios, including the notes from the Wiesbaden trials. When American engineers read the German line, "We have never seen range like this," they smiled, not in arrogance but in quiet satisfaction. Their gamble on frequency modulation, once dismissed by some in their own ranks as too experimental, had paid off on a scale no one had imagined. But even more valuable were the German insights themselves. The reports were meticulous, full of circuit diagrams, comparative measurements, and engineering commentary. In post-war debriefings, former German engineers admitted their admiration for the American approach. Rugged, simple, and standardized, one remarked. Our philosophy was to make perfection for the few. Theirs was to make reliability for the many. It was a lesson that would shape the future of global communications. In the years after the war, FM technology, once a battlefield secret, spread rapidly into civilian life. Commercial radio broadcasting adopted it for its superior clarity. Police and fire departments used FM sets inspired by wartime designs, even early NASA and NATO. Communication networks traced their lineage back to the same engineering principles that powered the SCR-300. For Germany, the experience left a lasting mark. Post-war companies like Telefunken and Grundig incorporated many of the practical lessons from American mass production philosophy. Efficiency, interchangeability, and modular design became the new benchmarks. In a strange twist of fate, the wartime admiration of American radios helped inspire Germany's post-war industrial revival in electronics. Military historians later noted that the capture and testing of those radios was more than a technical curiosity. It was a symbol of a shift in warfare itself. In the modern age, victory would no longer belong solely to the army with the best soldiers or the biggest guns. It would belong to the side that could connect its forces fastest, clearest, and most reliably. As the Cold War dawned, both NATO and Warsaw Pact armies built their strategies around one fundamental truth. The Germans had learned the hard way. In war, information isn't just power, it's survival. In the dim glow of that German lab in 1944, when the engineers first powered on the captured American radio, they didn't yet know they were witnessing the future. They heard a voice clear, steady, alive, traveling farther than any of their own could reach. That voice didn't belong to a single soldier, it belonged to an idea. The SCR-300 and its successors were more than just tools. They were bridges, links that bound platoons commanders, tanks, to infantry aircraft to ground forces. They turned chaos into coordination, isolation into teamwork. And for every American soldier who pressed that transmit switch, there was a quiet reassurance no matter where you were. Someone would hear you. For the Germans, the revelation was humbling. Their precision engineering, so celebrated in the early war, had been eclipsed by something less elegant but far more effective. The Americans had built their radios not for perfection, but for people. That difference proved decisive. When the war ended and the world began, rebuilding the lesson of that captured radio endured. It whispered to every designer, every general, every engineer, that technology is only as strong as its reach, not in distance, but in how many lives it connects. Somewhere in the ruins of that Wiesbaden lab, the old American radio likely gathered dust, its tubes cold, its signal silent. But its message had already travelled farther than anyone could measure. Because in the end, it wasn't just a story about range. It was a story about understanding the moment. One side realized that war, like communication itself, belongs to those who can listen farther than anyone else.